Hallo, guten Tag. Mein Name ist Friedemann Karik und ich heiße Sie recht herzlich willkommen hier bei den Me Future Talks von Mercedes-Benz. Hier bei den Me Future Talks bietet Mercedes Ihnen nicht nur eine kleine Sitzgelegenheit an einem anstrengenden Messetag, sondern sozusagen auch das Gespräch an über die Zukunft der Mobilität. Wie Sie sehen, werden hier allerlei Themen verhandelt, von der Elektromobilität, dem autonomen Fahren, dem Carsharing und der Vernetzung, sozusagen die Megatrends der Automobilbranche in der Zukunft. Eine große Rolle spielen dabei aber auch neue digitale Dienstleistungen und Sie werden Einblick erhalten in neue Arbeits- und Produktionsprozesse bei Mercedes. Stichwörter sind hier vor allem Startups und die Smart Factory. Da Sie wahrscheinlich nur heute hier auf der IAA sein können, können Sie natürlich nicht alle interessanten Future Talks hier live miterleben, aber Sie haben natürlich die Möglichkeit, über das IAA-Special auf der Mercedes-Benz-Webseite alle vergangenen und noch folgenden Talks mitzuverfolgen. Jetzt, in diesem Talk, möchten wir uns einem ganz besonders spannenden Thema widmen, nämlich der Artificial Intelligence, der sogenannten künstlichen Intelligenz. Und dazu haben wir einen Mann eingeladen, der von weit her extra hierher gekommen ist, um mit uns darüber zu sprechen. Dr. Kal Mos ist Vice President von Connected Car UI and Telematics bei Mercedes-Benz R&D im Silicon Valley. Wir wechseln jetzt also ins Englische. Ladies and Gentlemen, all the way from California, USA, this is Dr. Kal Mos.
Thank you.
Hey, nice to have you here.
Nice to have you.
Please join me at the table. So, Dr. Mos, it seems like in our world today, everything is getting more and more intelligent. The smartphone, of course, my house, my fridge, my shoes maybe. Where does it lead us?
Well, it will lead us to more intelligent machines. If you get experience with some intelligent machine around you, you will actually ask for more. We as humans, our expectation changes. And once you use something that's smart, you will ask why it cannot even get smarter, why this machine is not as smart as this one. So that process will continue, and we will always expect more.
So, could you say, is it correct that smartness in a technology, in a machine, in a thing, now is a nice to have and will be a must?
It will be a must, and that's why the whole area of programming is changing. The way we wrote programs in the past, as you can see, we actually create programs for the computer, and we tell the computer what to do. So if you look at the picture, and I want the computer to identify this picture, I will basically tell the computer, okay, look for eyes, look for nose, look for whiskers, and if you find all of these things, maybe it's this kind of animal, maybe it's a cat. I teach the computer, basically, I create a program for the computer to identify that image. We're moving from that to a new paradigm in programming. We're moving to a machine learning way of teaching the computer by training. So basically what we do here is that we give the computer tons of pictures, thousands and thousands of pictures, and tell the computer, this is the cat. We train the computer. We don't tell the computer what to do. We train the computer. And once we do that, anytime you can see a picture, the computer will have the intelligence to identify this. So that's just a simple example of how we are using machine learning to actually add this intelligence to machines, all machines around us.
So when I learn as a human being, I learn slowly, but I do learn. Context is king, because I can understand what kind of information is valid and relevant for me and what not. But how does a machine discriminate?
Yeah, so context is king. It's very important, because what we actually do with machine learning is that we create a pattern for the user. We observe what the user is doing, and then we create a pattern. And that pattern depends on the context. What you do in the morning is different from what you do in the afternoon. What you do when it's sunny is different from what you do when it's raining. And we use that context selectively in order to understand what the changes that are happening in that pattern. So you can look at the machine learning and you say, okay, with that context, what will it do for me? What will it actually enable us to do? Machine learning is very useful in personalization because once it understands your pattern and understands the context around it, it can give you an experience that's just personalized for you, only for you, based on your behavior and based on the context around you. It also can enable dynamic behavior. So as your behavior changes based on time, maybe you have a different, you move to a new house and you have a new address. Maybe you actually get a new job and you go to a different location for job. As your behavior changes, that dynamic behavior can be detected and predicted by the machine learning algorithm. And also for complex tasks, one of the important things with machine learning is that it can aggregate multiple complex tasks and provide a very simple way of doing it. So instead of you doing multiple things as you get in the car, all of these can be done for you in the background. So these are all the things that we can do once we understand the context around the user.
Astounding, and still, forgive me, sometimes it sounds like science fiction to me. Isn't it a huge step?
Actually, it's been happening for a while. Machine learning is not new. Machine learning is a science that's been going on for more than 50 years. What happened recently is that we actually have more things that make it possible today. We have lots of data. We have lots of sensors around us. In your smartphone, there are tons of sensors. In the car, there are hundreds of sensors. We collect lots of data in real time. And this data actually enables us now to have a very, very clear image of what's going on around you. So we can understand the context in a better way. We also have a very powerful computers that we can use, whether it's on your smartphone, in the car, on the server in the cloud. We have a huge progress in the processing power today that enables us to crunch all of these data. And from this data, we can come up with models and patterns. And of course, lots of people worked very hard on creating a very smart algorithms that enabled us to use today in order to understand the data that we are collecting. So these are all the things that made that possible today.
So in the end, for me as a user, what is the key objective of this more and more complex technology? Isn't it to make my life easier?
It is, absolutely. I mean, that is the final goal. Like, if you look just one example for the user interaction, and that is the example we're going to talk about today. If you just look at that, there are lots of things you can do with machine learning. I just listed here 5 of them. But we can create what we call behavior modeling. I could create a model for your behavior, and I can use that to predict what you're going to do next. I can use the machine learning to create an adaptive UI. So if you sit in the car and you're using different things in the car, maybe the things that you use the most, maybe I can bring this to the foreground, for example. User identification is another area. Very important, of course, for me to create a pattern for you is to understand who you are. So as you get in the car, I need to know who you are, and I can use machine learning to enable that. Action automation is important at one point when the algorithm inside the car is 100% sure that this is actually what you want to do, I can execute that. So if you get in the car and it's snowing outside, and every time it's snowing outside you turn on the heater, maybe I can just execute that for you. And that is what we call action automation. Based on the confidence in the prediction, I can even execute that. And then the last thing is actually a very important thing, is that how you can use machine learning to predict what the user is doing in the physical space inside the car. As you sit inside the car, you look right, you look left, you extend your hand, you do certain physical action inside the car, and machine learning can detect all of these and try to give us a picture of what you're trying to do in the car, so we can act based on that, and we can provide you a feature based on that.
Let's stay inside the car for a little bit more. What does it mean for your product? What does it mean for this area of mobility for the car?
So what it means is something like this. If you look at this is Concept EQ. This is the car that you have on the main show floor downstairs. And as you look at it, it's a very beautiful car. It's one of the things that you would love to look at. But behind the scene, we build the intelligence for these cars. So E for electric, Q for intelligence. And we build that intelligence. And it's not just a concept. What I actually wanted to show you today is a product. And that's why we have a car here, in order to show you a product. And that product, what we call is AI on the edge. And before we can talk about AI on the edge, I want to talk about traditional AI. So AI has been going on for a while, and it's been done by big companies around us, Google, Amazon, other companies. When you go to Amazon and it tells you, OK, well, maybe customers like you probably buy this book and buy this kind of product. What they are doing actually is that they are running artificial intelligence and machine learning algorithm in the cloud. So you can see it here. You can see in the cloud, they have their algorithms in the cloud. They have the training for that algorithm happens in the cloud using the user data. What happened on the edge is, edge in this case is your computer, your tablet, your smartphone. What happens on the edge here is that you just input data. You input data and you get the results. But all the intelligence and all the training and everything happens here in the cloud. In our case, we don't have this luxury because even though all the cars we make actually comes out of the factory with connectivity, we cannot make sure 100% that you connected all the time. So we have to make sure that the car will provide you with the intelligence even if you're not connected. So we build everything on the edge. And that is the AI on the edge that I want to talk about. So we put the model on the edge, inside the car. User interaction, of course, happens in the car. And then we do the training, and we work with the user data inside the car. So all the actions happen inside the car. And you can see the connection to the cloud and connection to the lab is all dotted lines, which means it's not guaranteed. With that actually comes a lot of challenges. With doing it this way comes a lot of challenges. And I can just explain to you some of those challenges. So if you look at this situation, of course, we cannot guarantee bandwidth, so I can't react very quickly if anything happens, because I'm not sure that it's connected. So it really needs to act and behave without connectivity. We have limited resources in the car. Car has very powerful computers. It has a lot of memory today, but it's not compared to what you have on the cloud. On the cloud, you have servers and you have data centers. So in the car, we have to be very conscious about the amount of memory we're using, amount of processing power we are using. And also, we are powered by battery, which means that I cannot run 24 hours. I can only run while the car is running. I can run my algorithm and the training while the car is running or while the car is charging if it's an electric vehicle. And then the algorithm is on the wild, which means I have to create that algorithm, put it in the car, leave it with the customers, and it will have to learn on its own after that in the hands of customers.
This kind of standalone AI sounds far more complex and even prone to mistakes. At what kind of stage of planning are you with this edge technology?
We are actually further than we'd expect, and that's why I brought the car. It's a production car. So what I wanted to show you is actually a product, and I asked one of our engineers from Silicon Valley to come to present it for us. So I would like to introduce Thomas Winkler from our Silicon Valley office. And he will actually be in the car showing us how it works in the production car. And what he's going to show us is a module that we developed in our Silicon Valley office. We actually validated this model for 3 years. We basically had multiple cars running around for 3 years, collecting data and training the model and validating the model. And we use sensors from the car in order to train that model and provide this contextual, as you mentioned, the contextual intelligence to decide the behavior of the customer depending on the context around them. So one simple example for this is that if you do something every Monday morning, then there is no need for the car to wait for you to do it after a few weeks. After a few weeks, the car can just show you that and offer you that. And that is the demo that I would like Thomas to show you inside the car. So maybe we switch to you, Thomas.
Yeah, hello, everyone. OK, we got the screen. So the first thing you want to do as a driver is to enable the feature. So in the settings, you just set the check mark here for allow destination suggestions. You only do this once, of course. So for example, when you get the car, you set this to on. And what this does is once you enabled it, the car will start learning the habits of the driver, and it will try to observe patterns and find patterns in your daily routines. So as an easy example, let's say after a couple of weeks, the system might have learned that in the mornings on certain weekdays, instead of going straight to work, you are going to the fitness center instead. So in those cases, after a couple of weeks, the system would just show the fitness center as the top prediction, and you can just be on your way. So let me show you how this looks on the actual UI side. So loading up here is our previous destinations list. Here on the bottom, we have all of our previous destinations as we know them from before. But here on the top, actually, the 3 items here, those are actually coming from the machine learning module. So those are actually based on what the car has learned about the habits of the driver. So in this case, I can just easily start route guidance by selecting one of those destinations. So the car will also use the current time of the day and the location to kind of customize what it will be predicting. Another interesting thing to mention is that the system, of course, will get smarter over time. So, of course, it can observe you, and it can get smarter the longer it can do that. But it can also kind of look at the prediction it's making and compare it to where you actually ended up going to. So this means even if the system is initially wrong with its predictions, it can compare these things, and if it was wrong, it can learn from that as well. So it will continuously improve in that sense as well.
But Thomas, excuse me, one question, because a route like home to work or home to fitness center, for me, because I do it every day, of course, I know that. I know that route, I know that destination. Are there any advantages in this case also?
Yeah, so that's a really good question. So what we have seen since live traffic features getting really good recently, many people like to have route guidance active as often as possible, just so that they can make use of traffic-aware routing. So our goal is basically to make it as easy as possible for people to start their route guidance and be on their way.
So when we talk about the machine learning, studying my behavior, what are we talking about? Like, what kind of length of time does it need? Does it take months or years to learn that?
So it, of course, depends on the person itself, on how predictable you are. But generally, to say, after a couple of days, you already get some pretty good predictions. And after a couple of weeks, it will get really, really good. And as I said before, the longer the car can learn about you, the better the predictions will get over time.
Okay, gentlemen, I'm convinced. Sounds very good. Now we have this car up here on the IAA, but when can I buy it? What about streamlining this kind of technology?
So the cars that are coming out of factory will have intelligence. Every year we will have more and more intelligence. That process already started. We put a brain in the car, and we keep growing that brain. So we looked at few sensors, and we created a model based on your behavior. But we look at other things now. So in our research labs now in Silicon Valley, we look at other things we can add to that brain. We look at how we can identify your emotion in the physical space, how we can get environmental sensors into the model, how we can even include some social information about you, or how we can add some data from the web and from the news about what's happening in the environment around you. So these things will help us to grow that brain and make it even smarter and make it even more customized and personalized for your case. And remember, all of this information actually lives in the car, so privacy is 100% guaranteed in this case. That model is on the edge. The data is on the edge. Everything is inside your car. It doesn't get out of the car.
So a system so powerful, so close to me in a way, so familiar with the time, it needs to have a name. Like, is it a friend, or how would you call it?
Absolutely. So that's actually what we are looking at the future, is to create what we call digital companion. The car becomes your digital companion. It knows your habits. It knows your things that you like. It knows where you go to. It knows lots of things, and then you can have a conversation with your car. So the car becomes more than just a machine you are using. It becomes a digital companion. That's our goal.
Great. So thank you for this point of time, for this enlightening glimpse into the future. Maybe you guys have a question for Dr. Mos right now in English or German. I try to translate. That would be the moment. If not, I think you can spread out and learn a little bit at the stations where people can teach you and tell you more about that. We have one. Please.
So nowadays our lives are constantly changing. How fast can the car forget about habits that we are not using anymore, for example?
That's a good one.
Yeah, very good question. So big part of that algorithm that we put here is to give you control over it. So you can actually stop it from working for 24 hours if you want to. You can say, okay, don't learn anything about my behavior for 24 hours. Or you can come sometime and say, don't learn about my behavior at all. I don't want this car. I'm borrowing this car for a couple of weeks. I don't want the car to know anything about me. Or if you're selling the car, you can come and say, okay, it was great the last 2 years. You learned a lot about me. Erase everything. You have full control of that. So you control your data.
So it's completely customization.
Yes, that's very important because, again, the car starts to know you and becomes very close to you. So you have to have control over this kind of information that you put in the car.
That's good news, yeah. Any more questions? There were another one.
Yes, you said that all the data is on the edge, means in the car. What is if I have more than one car and I would like to use the data from one car to drive into another car? Doesn't that mean that the data is not only on the edge but needs to be in the cloud, more or less?
So as we release this in stages. So in the first generation, we release it and we keep all the data in the car to get the customer familiar with the process. And then in the next generation, we actually enable customers to move data from one car to the other. And you can do that either by using a manual thing like a USB drive, or you can use it through the cloud. We give customer all these options because different people will feel comfortable with different ways. Some people don't want the data to live in the cloud. Some people want to control the data physically. So we give these options. But the first generation we started with, we just keep it in the car. And we just give you the option to have it or erase it. But you will get your data eventually through the cloud if you allow that in the future.
All right. So I think we have a wrap. Thanks very much, ladies and gentlemen, for your attention. Thank you, Kal und Thomas.
Thank you very much
for coming here.
Thank you.
Have a great day at the IAA.
Vielen
Dank Ihnen. Ich darf Sie noch kurz hinweisen. 15 Uhr auf der Urban Stage geht es weiter mit Shared Mobility und meiner Kollegin Sandra Ries. Und hier machen wir weiter um 15:30 Uhr, um 3:30 mit einem Car Talk zum X1 mit Julian Hiller. Ich danke Ihnen. Schönen Tag auf der IAA. Bis dann.